Greetings all. Plenty of progress on the 5 GHz uplink RF chain. If you haven't seen the engineering report from last week, then check it out in the link in the notes. Some important additional information is that measurements of the second order harmonic for the Skyworks solution turned out to be negative 42.5 dBc. There is a lot of optimism about this solution, and I'm hoping we can show off the progress at Dayton. Speaking of Dayton, team planning for our presentation on Friday evening at the Tapper AMSAT dinner and at the booth in the hall will kick off on Monday. There are several people that have volunteered to help present at the dinner, and we will work out who says what over the next week or so. This will be a fun and accessible talk. If you're at Dayton and infiltrating another event, know that our home base is most likely going to be the AMSAT booth in the hall. Please feel free to come by and leave a message or hang out. I'll be there with as much stuff as I can bring, and we'll make a point of occupying the booth, to defend it from the red team. There is a conference coming up at Virginia Tech. It's a wireless symposium. Here's the link. I'm thinking about going, which means I still have to ask my housemates, but might have already registered. Don't rat me out. If you're near VT or at VT, then let's meet up and hammer out some Phase 4 ground details. The Google Forms method for cutting up work continues with 2 new initiatives this week. We kicked off a dynamic QSL card project and got a team leader and team formation. This effort is the first web app for Phase 4 ground and is supposed to produce a beautiful visualization of logged contacts between one or more stations. This is an algorithmic graphical arts project that will blaze a trail into our web app methodology. Phase 4 ground will not have traditional software packages. You will use web apps, either in the cloud or served directly from the radio to access the radio functions. You will be able to write your own if we get our act together and document it well enough, which is the intent. A big thank you to Steve Conklin for stepping up and taking on this job. Figuring out the web app radio stuff is non-trivial and will provide a large amount of leverage for all the other apps that we envision, ranging from your regular RagChew app to emergency communications ICS forums to apps that monitor or filter or alert you to communications opportunities or situations. This is important stuff. Another task that kicked off this week is the receiver GNU radio project's definition. I have one volunteer here besides myself, and I'm looking for more. This is the effort that will specify what the blocks for our open source receiver do. The implementation of those blocks is another task, possibly done by the same people, but not necessarily. Our job is to take the DVB S2X standard and specify what blocks are needed in GNU radio in order to provide the functionality required. We're doing an adaptive coding and modulation version of DVB S2X. Our stream management is the DVB generic stream encapsulation protocol, which is simpler and lighter weight than using MPEG streams, and it directly frames up IP traffic for shipping over Phase 4 ground. Importantly, the modulations that we're using already exist in GNU radio. This process will identify blocks that already exist as well as specify blocks that are needed. We will not be reinventing any wheels. If we need new rims, though, we'll make that happen. We will be implementing as much as possible as RFNoC, which stands for Radio Frequency Networks on a Chip. We've gotten a lot of support and encouragement here, and it's just too amazing of an opportunity to pass up. RFNoC is to FPGAs as GNU radio is to general-purpose processors. For most flow graphs and SDR implementations, there is a limited ability to modify the code for the FPGA part of the system. RFNoC provides a framework and a workflow to partition radio designs between the processor and the FPGA in a way that better utilizes the FPGA. The problem that we're having in SDRs right now is exactly that, the underutilization of the FPGAs. There are expensive and not so expensive ways to get into FPGA design. We're actively discussing and reporting development and evaluation boards that allow entry-level into FPGA radio development. 2 that we discussed this week are the Kickstarter success Spartixed and the commercially available Red Pitaya. The Red Pitaya has an ADC and a DAC I/O, 2 of those, 2 channels, and supports a small Zinc system on a chip. The Zinc, as you probably know, is a combination of an ARM processor and programmable logic fabric. Being on the same chip, you get a substantial performance bonus over systems that have the processor and the FPGA on separate devices. This is a very exciting time for amateur radio, digital, microwave, and satellite. If this is something that interests you or you feel like you want to support it, then please join ARRL, AMSAT, and TAPR. Projects like Phase4 Ground simply can't exist without the support and promotion of these organizations. If you want to join our team, please contact me or go to the link in the notes to apply. All our work is open source on GitHub. Search for Phase4 Ground. Link is in the notes. And we have an author alert. Our very own Eric Nichols, KL7AJ, has written a book called Digital Storage Oscilloscopes for Ham Radio, which is available from ARRL. The link to go to the book, to check it out and buy it, is also in the notes. Hey, congratulations, Eric. We are totally proud of you. All right. See y'all at Dayton.